Welcome to the 7th video of section 3. We have examined some of the low-level building blocks in the previous videos. Now, it is time to examine a larger type of building block, page objects. What kind of creatures are these page objects, and why should we care? Earlier, we saw an example of 3 different page objects. We extracted them from an example where we navigated through the documentation for WebDriver. The reason for extracting them is that we need to separate navigation and validation. We didn't want to tie the navigation through the documentation to the test. There is the simple reason behind the pattern page objects: separation. The reason for separation is that it is good to honor the single responsibility principle. That is, each thing should do one thing and only one thing. A page object is an abstraction of a page in a web application. That is, we should represent each page, or sometimes a smaller part of a page, with a Java object. This Java object knows how to interact with the page. It can return elements and values from the page so that they can be asserted in a test. The Java object contains logic that is used for interaction with the web page. It will, therefore, effectively remove any page-specific knowledge from a test that implements the flow in the web app. The next test doesn't have to be aware of implementation details, such as the name of a link that should be followed to find another page. The type of low-level knowledge is abstracted away from the test. This is very handy the day someone decides that the web application needs to be restructured. Moving things around will probably break the tests. But if all the navigation details are hidden, it might just as well mean that the test will be okay again when the page objects have been updated. The page objects should never perform assertions about the web application. All these assertions should be done in the tests that use the page objects. The page objects should be able to return the status about the page. An example could be the title or the value of any field. In our example, we have returned the text of a heading that will say at a later time. A page object may assert that its internal browser is actually pointing to the page that it's expected. This can be done in different ways, but a simple way is to throw an exception when the page object is created and the current browser is not pointing at the expected page. If you add that type of assertion, make sure that you throw an exception that is specific to either the page or your application. Don't use JUnit to assert this. If you use JUnit to assert that you are on the correct page, then you would tie the page object to a certain test library, and that would not be very wise. It is a lot better to allow the test to be written using any test library, and not force the choice of test library from the page object implementation. So, we have discussed about page objects, and we have also seen an example. Let us now create a new example where we can use some already existing page objects. We would reuse some of the previous work, so we will once again verify the WebDriver documentation. But this time, we will verify the heading for the page objects section in Test Design Configurations page. Let's see what we are actually going to test and verify. Visit www.seleniumhq.org. Click on the Documentation link. Then, click the Test Design Considerations link. And go to Page Object Design Pattern section. We will verify this heading in our example. Let's start with the test and implement it using some existing page objects. Our existing page objects are Selenium HQ and Documentation. We have implemented one new page object, Test Design Considerations.java, and the test file is testdesignconsiderationstest.java. Notice the easy flow when the page objects are already done. This is the way we want to implement our tests, using existing building blocks and combine them in clever ways. Using page objects that already exist will allow us to concentrate on navigating the application and verifying it without worrying about low-level details, such as how a certain element is located. This increases the abstraction level in our tests. We should use a domain-specific language, that is, the page objects, and build the test from there. This is a lot easier to maintain, as compared to a low-level implementation where we mix things like locating elements with what content or behavior we are expecting. Let us take a look at a new page object that we have added for this example. TestDesignConsiderations.java. This page object follows the same pattern as we saw earlier. The browser is set when the object is created. We will verify that we are on the expected page. This is an enhancement to the previous example. If we end up on the wrong page, then a custom exception will be thrown. There is a specific method that locates the page objects section on the page and returns the text in the h2 tag. This may seem like it's very little code, and it really doesn't do a lot, but it does enough for verifying the heading of the page object section. It does one thing, and it does it pretty well. All of your methods in your page objects should be similar to these small methods. If they are larger, then consider breaking them into smaller methods. This turns very easily into a discussion about clean code that is out of scope for this course. Nevertheless, clean code is extremely important in test code as well as production code. Now, let's see how is a wrong page exception implemented. It is a very small exception that really doesn't do anything. It just delegates to its ancestor to create a runtime exception with the message. But it's important not to throw a raw runtime exception. The reason for this is that if we use custom exception, it is a lot easier to understand where the exception comes from and what it represents. Then you may wonder, why didn't we use an exception? Why extend runtime exception? That question is again a discussion about clean code. A complete answer can be found in the book Clean Code, where an entire chapter is dedicated to exception handling. My short motivation here is that we wish to throw our custom exception, but don't want the surrounding code to bother that this might happen. If it happens, then we can't really do much about it, so the exception will fail. There is no good reason why we should add additional cognitive burden by forcing the code that uses this page object to handle a checked exception as well. Now let's run the example. Go to the Projects folder, press Shift plus right-click and select Open Command Window here, and execute the Maven command here. And there you go, the build was successful. The page object should represent a page or part of a page. It should be used to interact with a page, but not used when asserting some page content. Assertions should be done in the testing framework that you use. This will allow you to use whatever testing framework you want, without affecting the interaction with the page you want to test. Page objects should not be used to define the flow through a web application. The flow should be defined in a test. The flow probably means that you will use more than one page object in a test and navigate from one page to another. In this video, we have taken a good look at page objects. There are still some advantages of using WebDriver that you want to be familiar with. Join me in the next video where we will see some of them.